Now we're changing from scientific notation to standard notation, and it's going to be pretty much the same logic as before when we're converting from standard to scientific notation, so make sure you know how to do that first. Now, all we have to think about really is this a big number or is this a small number? Okay, so let's take a look at our first example, 3.38 times 10 to the 3. Now, I know this is a big number because we have a positive exponent here. So that means that from our original number, our coefficient, this is what it's called, we're going to be moving the decimal place in the right direction to make this number bigger. So we're going to move it 3 times to the right. 1, 2, 3. Here's a new decimal place. And that means that since I have an empty little spot right here, I'm going to put a space filling 0 right there. So it's going to be 3, 3, 8, 0, and that's going to be the standard notation. Alright, let's take a look at our second example. We have 6.00005 times 10 to the 8. Okay, this is a super big number. It's a positive 8 exponent. So we're going to write down this, and we're going to be moving the decimal to the right to make it bigger. We're moving it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Here's my new decimal place, and every time I have a little valley, I'm going to put a 0 right there. So I have 6,000,05, 000, and now I can put my commas afterward. So I have 600,005,000 kilojoules per hour. This is just how much energy per time there is. Okay, let's look at our third example. We have 2.105 times 10 to the negative 1 grams. And now this is a negative exponent, so this is a small number. And if we're talking about a small number, we have to move the decimal place to the left to make it an even smaller decimal number, right? So we're only going to be moving it to the left 1 time. So here's the decimal place, 1. Here's a new decimal place, so it's 0.2105 grams. Since all of those are, or since there's so many of those non-zero numbers, you have to write them down. Okay, let's see. Fourth example, we have 6.028 times 10 to the 4. This is a big number because we have a positive exponent, meaning we're going to be moving our decimal place to the right this time, and we're going to be moving it 4 total times. 1, 2, 3, 4. So there's a new decimal place. There's 1, 0. 60280. Now I can throw in the comma. It's 60,280 liters. Alright, we have just one final example. We have 7 times 10 to the 16. Oh my goodness. 7. Here's the decimal. Now this is a very, very big number. We have a very large positive exponent. We're going to be moving the decimal to the right 16 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? Something like that. Now you know that there's going to be 16 zeros, so I'm not going to write it twice. I'm just going to go ahead and write it down. That's my answer now. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now I can put my commas. So there is 1, 2, 3, 4, 5 sets of 3 zeros. I don't even know what this number is. 1,000, million, billion, trillion, quadrillion. Oh, never mind, I do know it. It's 70 quadrillion. 70 quadrillion kilometers. Alright, I hope you found this video helpful.